I just came over from, I'm sorry I missed the morning session. This is my third time at the Data Center Efficiency Summit. It's always incredibly valuable. I was over just down the street at the Santa Clara Convention Center at our internal Tech Pulse event, which is an annual Yahoo event where people from about a dozen countries come to share best practices around Yahoo. And that includes the folks in brand marketing, the folks in, who design the algorithms, search, all sorts of stuff. This project is one of the ones I'd say that this year people are most excited about. Data centers don't tend to be the sexiest aspect of Yahoo, but the question here is, well, geez, we're able to achieve 17% efficiency increases in an existing facility through a retrofit. People are always saying, oh, you can't do much with retrofit. 17% increases. So the question is, if you're starting with a blank sheet of paper, with bare ground and a new data center, what's possible from the standpoint of airside economization. So that's what this project's about. So data center in Lockport, New York. We had a grand opening for this September 20th. Part of the reason we chose Lockport, New York, a lot of factors go into data center location, is design. We wanted something whereby we could use historical data for whether an environment where it can really maximize use of outside air cooling. South of the Mason-Dixon line, this sort of project loses some efficiency because you got many more hot and humid days. We wanted to do something that was a pre-engineered building for speed of construction, efficiency, and low cost. We did a skid-based pre-engineered electrical cooling and other infrastructure in addition to the envelope, the actual building. We also were willing to accept a greater range of humidification and temperature, which we'll talk about in a bit. That ASHRAE envelope, we're like, let's exceed that. Let's talk about pushing the envelope on that one, literally and figuratively. We've got a patent-pending design. It's called Yahoo Compute Coop, affectionately known as the Yahoo Chicken Coop. I'll show you some pictures of that in a second. 100% outside air cooled, supplemented about 212 hours a year by a direct evaporative cooling system, so eliminating the need for chillers. And using, in that outside air, taking advantage of the temperate climate and the lake winds up there in upstate New York. We told the folks when we came to Buffalo, we really love your weather up here. They didn't really believe us because they don't hear that very often, but it was a pretty integral part of the design. No raised floors, concrete slab. That and the pre-constructed steel building helped out a lot with the capital cost of this project as well. So some pictures. Upstate New York, this is actually not a new idea. Free cooling, everything old is new again. Back in the days before big mechanical chillers and brute force cooling, people designed their buildings very cleverly. This is an old aluminum smelting factory in upstate New York, in Buffalo. Very long, narrow buildings. They're kind of built crooked on property, in part to take advantage of prevailing winds. Really tall buildings that vent out all the hot air when needed. Really interesting design solutions there that we definitely looked at, took into account, and borrowed from. Another inspiration was the chicken coop. When you're cooling off a chicken in an industrial facility, you're not using expensive chiller systems. You're figuring out a low-cost way to keep that chicken cool. They're throwing off a lot of BTU. Little servers do much the same thing. So we looked at some chicken coop designs in preparation for this as well. So with that in mind, we said, let's kill the chillers. This is sort of something, let's get rid of that chiller entirely. It's a high capital cost. We want to set up a situation where we're not running a chiller 24/7. Running the servers with a 75 Fahrenheit air intake for the majority of the year, sometimes higher, sometimes lower. And make efforts to avoid intakes exceeding 80 degrees Fahrenheit. We're also really running, again, this high-efficiency evaporative cooling technology. There are going to be certain times during the year in the middle of summer where we need that, and they'll be running the server intake between 80 and 90 Fahrenheit. Again, we're pushing the envelope on that ASHRAE standard that we're talking about here. We've tested that out in some of our other facilities. We haven't run into any problems. We had a level of confidence about going ahead and doing that in this data center. And basically, the idea was to create a building that's in and of itself a great big air handler. The construction of the building is intended to provide that air handler system that we've been trying to do mechanically in last generation data centers. Again, the ASHRAE standard, that little green quadrangle there in the middle of things, that's the standard ASHRAE 45 to 55% relative humidity, pretty narrow band of temperature. It's really expensive to keep temperature that narrow and humidity that narrow and that consistent. So the dotted black line is what we expect to see in terms of what we consider an acceptable envelope. Red line represents what we see, roughly what we expect to see year-round in Buffalo, about 34 hours per year average. Again, we're going to be running the direct evaporative cooling system about 212 hours per year. So 99% of the time or more, we're just relying on that outside air. So we tested this. Down in Cupertino, we said, OK, let's build a little test model and run it really, really hot and really, really cold. So we fired up the load banks to create a very hot Buffalo summer simulation. And then we bought a whole bunch of dry ice to attempt to simulate a Buffalo winter. I don't live in Buffalo. I lived in Boston growing up, so the winters there get pretty bitter. I don't think we got to quite simulating your average Buffalo winter, but we definitely got the temperature down there. By the way, the design for this, we submitted for an American Reinvestment Recovery Act award for green IT efficiency and actually got an award of $10 million for this design. One of the things, very interesting, they send you a little score of how you do. And on the one hand, they said, really innovative, worth looking at, exactly the kind of thing that this grant and project is trying to support. And in the con column, they're like, we're not entirely sure you're going to be able to pull this off. So at least they were honest with us. Here's what it looks like. This is phase one of the project. The building furthest to the left is the admin building. The other three are the first three modules. We've got another two that are in the process of being designed and built. And from dirt to up and running took about 6 months. That's another advantage of the modular pre-constructed design. Lower cost because you've eliminated the raised floors, eliminated the chillers, and also takes a little bit less time to build it. Which in the data center world, especially in our world, overbuilding and leaving a building empty for long periods of time or getting behind the 8 ball where you need capacity yesterday and don't have it are two things that keep us all awake at night. So that's very valuable. Here's a side view. You can see up top, I'll show you in a second, the inside of that cupola on top. That's where the venting is. Again, hot air rises. We've encapsulated the hot row for the servers, vent the air up there. You can adjust those louvers up there to either shut them, leave them open. If you're getting more air on one side, you can close one and leave the other one open. It's an extremely flexible system in terms of venting the air. Here's the inside, up top, those louvers. Most of the year, they're wide open. Here are the results we're getting. We did a full fit-out test. Like I said, we opened this in September. One of the things I'm tracking, and I owe back to the Department of Energy, is a 12-month study. What does this look like over a 12-month period? But the initial testing we've done in, I believe it was July, got a PUE of about 1.08 with the evaporative cooling. The aspiration, if we can site in areas that have an even more favorable climate for this, is maybe to have even lower evaporative cooling. Estimated savings of 36 million gallons of water per year compared to a water-cooled design, conventional water-cooled chiller plant. Not sewer discharge. You don't use water, you've got less sewer discharge. So about 8 million gallons of sewer discharge avoided per year, which for those of you who operate or work with large data centers, that's actually a pretty big concern of a lot of the municipalities you work with. Lower cost to construct than previous designs for all the reasons that I just talked about, and faster to build. So what's next? This is a design that we're planning on replicating in a couple of different locations. The other thing we're looking at is when you talk about PUE, you've got the 1.08 in this case. We're continuing to attempt to decrease the non-mechanical, the non-critical load as much as possible. But there's the whole one side of things as well. What can we do to reduce the actual IT load? We're also looking at what can we do to reduce the unnecessary AC/DC conversions at the UPS level. We think if we can tackle that problem, we can see another 30% savings on the power supply end of things, since we're maxing out the efficiency on cooling. Eliminating inefficient server fans is a big one. And then, of course, where can we take this design? Are there places where we don't need the evaporative cooling at all? And of course, we also recognize we continue as a global company to play in areas where they're very hot and humid, where this isn't necessarily an appropriate design. So again, we're looking for solutions that will apply in other areas as well. But for a lot of the regions that we're working in, this has been extremely successful, and we're excited to see what happens next.